Alrighty, before I begin the Lesson 5.3 notes, isosceles and equilateral triangles, and intro to proofs, it is so important that you use the definitions and theorems from your pink sheet. So if you haven't already, you need to go ahead and watch part 2 of the Lesson 5.0 pink sheet properties in order to understand the notes for today. Speaking of notes, let me go ahead and grab my notes key. Whoops, I just dropped my Apple Pencil. Okay, so we're going to go ahead and take a look at 3 figures right now, okay? And as you can see, my goal here is to figure out what x and y are. So it says find the values of x and y. Here's example 1. And if I zoom in, we need to make sure that we have an idea on what the heck is going on. Okay, first of all, I can see that we're dealing with 2 tick marks. They're both congruent. This is an isosceles triangle. Okay, this is an isosceles triangle. So we have to use the isosceles triangle theorem, which that's not that one, but it is this. The isosceles triangle theorem states that if the 2 sides of a triangle are congruent, then the angles opposite to those sides are congruent. So, yes, this is our given. You got these 2 tick marks here, indicating that this segment here and this segment here are congruent. So that means you have the angles that are opposite to those sides. As you can see, they're congruent. Okay, one more time. The angles opposite to those sides are congruent to those congruent sides. So this angle is opposite to this side, and then this angle is opposite to that side. Okay, so if I go back to the notes, you can see again these 2 tick marks indicate congruencies. So that means that this angle is opposite to this side, and then this angle is opposite to that side. Hopefully that makes sense. You're using the isosceles triangle theorem, and you're going to make sure that you mark those angles which aren't marked for you, right? So let me go ahead and choose a different color. So that means I need to draw an arc here and an arc here, because I'm using the isosceles triangle theorem. So what's next? Okay, so since this angle here and this angle here are congruent, that means that since this is 2x, this has to be 2x as well. Okay, so that means that has to be 2x. And since this is 2x, this is 2x, well, and this is 2x, that means that that angle is congruent to everything else. So really, this became an isosceles, or not an isosceles triangle. This isosceles triangle now is an equilateral triangle, meaning that all the sides are congruent and all the angles are congruent. Okay, so this isosceles triangle now became equilateral. And an equilateral triangle is an isosceles, because an isosceles triangle, what it means is it's that it has at least 2 sides. Okay, that's what an equilateral triangle is. It's isosceles and it works. So if I look at all these angles here, these are the interior angles of a triangle. And if I add the sum of the interior angles of a triangle, well, what is that going to give me? That's going to give me 180. So if I do 2x plus 2x plus 2x, that's going to give me 6x, right? And I will set that equal to 180, solve for x, which is going to give me 30. So x is equal to 30, okay? To find y, well, we know that this isosceles triangle became equilateral because we were basically marking our pictures. Yes, and we can tell that this is an equilateral triangle, so that means all the sides are congruent. I can set this and this equal to each other because they are congruent. So I have 4y minus 5 equals 3, so 4y is equal to 8, y is equal to 2. That's my answer. And that's all I needed to do for this problem, because my goal here is to do what? Find x and y. Okay? Example 2. I can see that this is an isosceles triangle. Right? Because you can see the two tick marks. And by the isosceles triangle theorem, which we've already saw, well, that means that angles opposite to those sides are congruent. So this angle is opposite to this congruent side, and then this angle has to be opposite to this congruent side. So I can go ahead and mark my picture. So this angle and this angle are congruent. So what else do we need to know? Well, since these two angles are congruent, this is 6x plus 8, yes? So that means that this here has to be 6x plus 8. So look, I have all the angles, and if I were to add these angles up, I should equal them to 180. So basically, I can do this. I can do 6x plus 8 plus 6x plus 8 plus 80. So 2 times 6x plus 8. The reason why I'm doing 2 times the quantity 6 plus 8 is because there are two 6 plus 8s, right? So I write it, instead of me saying 6 plus 8, 6x plus 8 plus 6x plus 8, I'm going to say 2 times 6x plus 8. And then I'm going to add the 80. And I equal that to 180, okay? So then I can go ahead and subtract both sides by 80, and I get 100. Then I'm going to do that trick that I did before. It's a long time ago. You can treat this parentheses as x, right? It's like you're solving for x. So this is like 2 times the quote x equals 100, right? So I'm going to divide both sides by 2, and I get 6x plus 8 equals 50. Then I'm going to subtract both sides by 8, so 6x is equal to, what is this going to give me? 42. So x is equal to 7. Okay, so x is equal to 7. So that's me solving for x. Now I got to go ahead and solve for y, and we can see that these two segments here are congruent. So I do 4y minus 2 equals 2y plus 2. So minus 2y minus 2y. So, and then I'm going to add 2. So 2y is equal to 4, y equals 2. Okay? So make sure that you have an idea on how to use the isosceles triangle theorem. Now we're going to go ahead and take a look at example 3. So example 3 is different because we have congruent angles. Okay? And since I have these two congruent angles, I need to go back to my pink sheet properties. And it says, with the converse isosceles theorem, if two angles of a triangle are congruent, then the sides opposite to those angles are congruent. So that means that this angle and this side, they are opposite to each other. So I should put a tick mark here, and that applies to this and this. So I'm going to go ahead and put a tick mark there. So if this angle is 3y minus 8, then this angle has to be 3y minus 8. So 3y minus 8. And you can see that this angle is 28 degrees. So I can go ahead and add up all these angles. So 3y minus 8 plus 3y minus 8 plus 28 is equal to 180. I'm going to go ahead and combine these two. So 3y minus 8 plus 3y minus 8, that's going to give me 6y minus 16. Don't forget to add that 28, set it equal to 180. So then if I combine the like terms, I get 6y plus 12 equals 180. So 6y is equal to 168, and y is equal to 28. That's me solving for y. Then I can go ahead and take a look at these segments here. They're congruent to each other, and they both have the x's, so that's awesome. Set them equal to each other. So 2x plus 6 equals 3x minus 6. So that should give you 12 equals x. Okay? So there you have it. That's me going through the first 3 problems of the notes. Now we're going to go ahead and get into that territory of congruent triangle proofs, okay? So, number 1, given that R is the midpoint of segment QS and segment PT, prove that the triangle PRQ is congruent to TRS. So, this time around, I have blanks, right? We're so used to having things filled out, but this time we just have blank 2-column proofs. So what I need to make sure that I do is I need to come up with a draft, right? I'm going to write a draft, and then I'm going to put it on my final draft. So looking at this, it says, given that R is the midpoint of segment QS and segment PT. So here, I'm going to go ahead and put a point at... I'm going to put a point, a dot on, R, since R is the midpoint. Now, if R is the midpoint, y'all, if R is the midpoint, well, what does the midpoint do to segment QS? Here's segment QS. Well, it's going to split the segment into 2 congruent parts, right? So that means that this segment and this segment, they have to be congruent to each other, okay? So if that's the case, then I should write that segment QR is congruent to segment RS. So segment QR is congruent to segment RS. And why? How did we know that segment QR is congruent to RS? Well, that's because of the definition of midpoint. And we can't forget that R is also the midpoint of segment PT, right? So, well, if R is the midpoint of segment PT, again, by definition of midpoint, it's going to split that segment into 2 congruent parts. So I should put 2 tick marks this time, right? So that means that segment PR is congruent. Sorry, let me go ahead and highlight this. Segment PR is congruent to segment RT. So segment PR is congruent to segment RT. And how did we know that they were congruent? It was definition of midpoint. Okay, so what else do we know? So I've done everything I need to do from my given. I marked my picture, I wrote some stuff. That's awesome. Let's take a look at the image now. So now I'm gonna go ahead and take a look at the image. Okay, so if I zoom in closely, what do we notice? Well, what do we know? Well, as you can see, if you have these 2 lines that intersect form an X, well, the angles across from each other are congruent. Those are what we call vertical angles. So this angle and this angle are congruent. Okay? So, that's awesome. Before I go do anything else, I want to make sure that we understand what we're trying to prove. We're trying to prove that triangle PRQ is congruent to triangle TRS. And remember, to prove triangles congruent, we have to use the 4 ways, the 4 shortcuts: side, 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 angle, side, angle, or angle, side, right? And, well, it's actually one of those things. So if I were to look at my picture, again, I'm dealing with 2 triangles, this triangle here and this triangle here. And we're going to go ahead and start labeling things. I'm going to use blue. So we can see that this segment here and this segment here are congruent and they correspond. So I write side here, side here. And I can see that this angle here and this angle here, they're congruent and they correspond. So I'll put an A. And then this segment here and this, sorry. This segment here and this segment here, they're congruent. So what do we notice? We can see that side, angle, side, side, angle, side. So these 2 triangles are congruent by side, angle, side, right? So now I'm just going to go ahead, since I have an idea on how to prove this, I know how to prove my given. I am going to put everything on paper, and that is putting everything in the 2-column proofs. So first of all, the first statement and the first reason, that should be very, very easy. All you have to do is copy and paste. So we know that R is the midpoint of QS, and BT. Okay, and how do we know? It was our given. So I'm going to write given. And number 2, well, based on the given, we can see that we have something that we're already used to. We've seen this word a lot in this course, and that's midpoint, right? So R is the midpoint of segment QS and segment PT, and because of that, it splits these 2 segments apart. It gave us QR congruent to RS and PR congruent to RT. So I'm going to go ahead and write this to 2. So segment QR is congruent to segment RS. And why? We said definition of midpoint. And then I'm going to say segment PR is congruent to segment RT. And that's still because of definition of midpoint. And then we're going to go ahead and write our vertical angles. So I don't say, yes, I can tell that R is this point, but I need to be very, very clear. I don't say angle R. This is not angle R. This here is not angle R, okay? This is the angle, where R is the vertex, right? So because of the vertical angles, I'm going to write, and using the vertex, angle PRQ. Angle PRQ is congruent to SRT. Or you can say TRS. It doesn't really matter. So SRT by vertical angles. And then the prove should be very, very easy. The prove should be right here. And I'm going to say triangle PRQ is congruent to triangle TRS. And that's because of, what did we say before? Side angle side. Okay, and then I'm done with the proof. Okay. Number 2, given that segment QR is congruent to segment SR and segment ST is congruent to segment QT, prove that the triangle QRT is congruent to triangle SRT. So QRT and then SRT. So what do we have to do? First things first, you're going to go ahead and look at your given, mark your picture. So QR is congruent to ST. 1 tick mark there, 1 tick mark there. Good. And then segment ST. Oh, whoa. Sorry. I did not pay attention. QR is this. SR is this. So 1 tick mark here, 1 tick mark here. Then we notice that segment ST is congruent to segment QT. So we cannot assume that segment ST is congruent to segment QR. It does not say that. It only says that segment ST is congruent to segment QT. So that means that I need to put 2 tick marks for each of them. Okay. So I'm done with that. Now, since I'm done with my given, I'm going to go ahead and zoom in. What do we notice? Well, we notice that these 2 triangles here, they share this particular side. So that means that they are congruent to each other. And we call that the reflexive property. So we're going to write RT is congruent to RT by the reflexive property. Okay? So I think I have everything. Because now I'm going to go ahead and look at the proof. That means that we're going to use side, angle, side, angle, side, angle, or angle, angle, side. In this case, it's just, if we look, well, this segment here corresponds with this segment. This segment here corresponds with that segment. And then this segment here and that segment here, the reflexive, they share that same side. So they are congruent. We put an S here. So it looks like we're dealing with side. So let's go ahead and take a look at our 2-column proofs. I'm going to go ahead and write my given. So segment QR congruent to segment SR. And we know that segment ST is congruent to segment QT. And that's because of my given. That's because of my given. And then the fact that we saw the reflexive property from the image itself, that is something worthy to write down. So I say segment RT is congruent to segment RT by the, I don't need to write that there, by the reflexive property. And then the last thing should be here, your proof. Triangle QRT is congruent to triangle SRT by side, side, side. Okay? So, we're done with that proof. Alright, let's go ahead and take a look at this figure here. Given that segment AB is congruent to segment ED and segment CA is congruent to segment CE, and segment AC bisects segment B, there's a lot going on with that given. Prove that triangle ABC is congruent to triangle EDC. So we're going to have to use those 4 shortcuts or one of the 4 shortcuts. Use one of the 4 shortcuts, right? So now what do I have to do is I'm going to look at my given, because these are the things that we can assume, and start marking them down on our image. So we can see that segment AB is congruent to segment ED. Actually, that's already marked for us. That's great. So I don't need to do anything. Segment CA is congruent to segment CE. Those are already marked for us. So I don't really have to do anything. I mean, you're more than welcome to just trace them, retrace them, or whatever, like highlight them if you want. And then we cannot neglect the fact that segment AC bisects segment BC. So here is segment AC. It is the bisector. So this is something that we are familiar with, because we've heard of the word bisect a lot in this course. And what does the bisector do? What does the segment bisector do? We need to go back to our pink sheets. And figure out what the segment bisector does. The segment bisector says that if a line, segment, ray, or plane is a segment bisector, then it intersects the segment at its midpoint. So we know that if you have a segment bisector, then you create a midpoint, and what does the midpoint do? It it splits the segment into 2 congruent parts. So let's go ahead and write that down. So since AC is a segment bisector, it creates a midpoint. Okay, so I'm going to go ahead and draw a dot at C. And when you have that midpoint, what does the midpoint do? It actually splits the segment into 2 congruent parts, where segment BC is congruent to segment CD. So I'm going to say segment BC is congruent to segment CD. And that's by definition of midpoint. Okay? So that's awesome. We have that. So what am I trying to prove here? ABC is congruent to triangle EDC. So this triangle is literally a non-factor. I'm only taking a look at these 2 triangles, seeing whether or not they are congruent. So let's go ahead and take a look at our image and figure out what's it congruent by, like which shortcut theorems. And I just noticed something here. Since there's a tick mark, 1 tick mark here originally, this should not have 1 tick mark, or this segment here and this segment here should not have 1 tick mark. In fact, it should have 3. Okay, so we have 3 tick marks there. All right, let's go ahead and write our stuff. So we can see that this segment here and this segment here are congruent, and they correspond. And I can see that this segment here and this segment here are congruent. They correspond. And then this segment here and this segment here correspond. So they are congruent by what? Side, side, side. Yes, so side, side, side is the way to prove it. And then I am going to go ahead and use my 2-column proofs now. So segment AB is congruent to segment ED. And then segment CA is congruent to segment CE. And then we can't forget that segment AC is AC bisects segment BD. And all of this is because of my given, right? This is all because you're given this, you write it here, and then you write the reason given. Freest points ever. And then what else do we know? We're going to take our given, right? We're going to look at the word bisect from our given. What does the bisector do? What does the segment bisector do? Well, remember, the segment bisector creates the midpoint. Okay? So I am going to write, since C is my midpoint, C is the midpoint of segment BD, and that is because of definition of segment bisector. Okay, so what happens if C is the midpoint to segment BD? What happens if C is the midpoint to segment BD? Well, it's going to split the segment into 2 congruent parts, right? So I will now write BC is congruent to segment CD, and that's because of definition of midpoint. Okay? And then lastly, my proof should be triangle ABC is congruent to triangle EDC. And that's because of side, side, side. Okay. All right, so given that the segment YX is congruent to segment WC, and segment YX is parallel to ZW, prove that triangle YXZ is congruent to WZX. Okay, so this here is already marked for us. We can see that this tick mark here and this tick mark here, those 2 segments are congruent. Now I'm going to go ahead and take a look at this one because it says that segment YX is parallel to segment ZW. So I need to go ahead and draw my arrows. Okay, so when you have parallel lines, they are cut by a transversal. Okay, so that means that these angles are alternate interior angles. So let me rewrite this. So you have parallel lines cut by transversal, so then alternate interior angles. Okay, so what are the alternate interior angles? You may not, and I'm going to say this right now, you cannot say angle X and angle Z. So cannot say angle X and angle Z. And the reason why, because angle X is this whole thing here, and angle Z is this whole thing here. I'm only focusing on this angle and this angle. Those 2 angles are congruent. Okay, saying angle X and angle Z, that's being ambiguous. You need to be very, very specific on which angles are being congruent. In this case, it's this and also this. So how do we name this angle? Remember, it's Y, X being the vertex, Z. So angle Y, X, Z is congruent to W, Z, X. So Cool, that's because of alternate interior angles. What also I notice, well, I can't neglect the fact that this, these two triangles here share the same side, right? That's the reflexive property. So XZ is congruent to segment XZ by the reflexive property. So now I have all that. I'm done with this, and then I looked at my image, noticed the reflexive property. That's awesome. Now I can go ahead and prove that the triangle YXZ is congruent to the triangle WZX with something, right? We can see that I should use a different color here. We can see that this side here and this side here, they correspond and they're congruent. We can see that this angle here and this angle here are congruent, and we cannot forget this side here, the reflexive property. So that deserves 2 tick marks. So S here and S here. So I have a side, angle, side. If we can see that, S, A, S. And then we have an S-A-S, side angle side, congruent by side angle side. So let's go ahead and write our given. In fact, I'm too lazy, so I'm going to go ahead and just put that right there and say given. And then I'm going to write, because we're going to go ahead and take something from our given, that those parallel lines, right? When you have those parallel lines are cut by transversal, and that means that this angle here and this angle here are congruent. So what did we say? We said this. So angle YXZ is congruent to angle WZX. That's because of not vertical angles, alternate interior angles. Okay, we're done with this. And then we notice that reflexive property from the beginning. So I say XZ is congruent to segment XZ by the reflexive property. Okay, so we can say that triangle YXZ is congruent to triangle WZX by, what did we say? Side angle side, right here, side angle side. So then I'm done with my proof. All right, given that segment JM is congruent to segment NK, L is the midpoint of JN and KM, prove that angle ML or MJL is congruent to triangle KNL. So real quickly, look at our proof compared to everything else. Okay, hopefully you saw that. Well, look at that. We're not proving that these two triangles are congruent. We're actually proving that these angles are congruent. Now, if you don't see those little triangles here, you're going to be dealing with a CPCTC type of problem. Okay? Corresponding parts of congruent triangles are congruent. And I'm going to get into that a little bit later on when we go from top to bottom over here. So let's go ahead and just focus on our given. It says a segment JM is congruent to segment NK. And these two segments are already marked for us, so I don't really need to do anything there. That's awesome. But it says that L is the midpoint to segment JN and segment KM. So here is my midpoint L. And since L is the midpoint of JN, segment JN, well, here is L and then here is JN. That means it's going to split the segment into two congruent parts. So that JL, so segment JL is congruent to segment LN. But L is also the midpoint of KM. So how many tick marks do I need? I only need 3. So L is the midpoint of KM. So that means that this segment here is congruent to that segment. So I'm going to write KL is congruent to LN. So that's awesome. Let me go ahead and zoom. What I need to look at, I'm going to look at MJL. So MJL and KNL. So these are two triangles. Are these two triangles congruent? Well, let's take a look. So this side here and this side here corresponds. This side corresponds with that side, and this side corresponds with that side. So triangle NJL is congruent to triangle KNL by side. And since this is what we need, because if these two triangles are congruent, this is where we can apply CPCTC. Okay, so that's the goal. Again, I'm lazy, so I'm going to put the given statement there and write given for my reason. Notice that L is the midpoint. Oh, no, we don't write that. Sorry. We know that segment JL is congruent to segment LN, and that's because of definition of midpoint. And then from here, so we wrote this and put it right there. Now we're going to go ahead and put this here. So KL, segment KL is congruent to segment LN, and that's because of definition of midpoint. So what else? And we see that these two triangles here are congruent. So I'll call that triangle MJL congruent to triangle KNL. And that's because of what? Side. And then since these two triangles are congruent, I can apply CPCTC. Okay? That means any corresponding angles are congruent. So here are the triangles. So that means that any angle that corresponds are congruent. That means that MJL is congruent to KNL. So these are congruent by CPCTC. So triangle MJL is congruent to angle MJL is congruent to angle KNL. So if I said angle M, that's congruent to angle K. If I say angle J, that's congruent to angle N. If I say angle L, that's congruent to angle L. But if I was very specific, then I said angle NJL is congruent. So angle NJL is congruent to KNL. So that's me using CPCTC.